Good evening. We're here to take a look at section 7.1, starting into new territory for ourselves as we learn new content in this remote learning mode. So we're going to take a look at radical expressions and functions and see how this applies, moves us on to being able to do section 7.1 homework, and then we will look at 7.2 and so forth. Okay, radical expressions and functions. So we're going to look at radical expressions. We're going to look at square roots, cube roots, and other type of roots as well. So square roots and cube roots, we'll get to see what those are. So first of all, we start off with a square root, and it's a number b. Remember, b is any letter at the beginning of the alphabet, stands for an unknown number. Not really a variable, but a number that once we find out what it is, it sort of sticks. So b is some kind of number that when we take it and square it, it equals a. So b would be called the square root of a, of number a. So what does that mean? Let's just put some numbers in here. If I use the number 3, if I call b, I say, hey, b, you're 3. Then what happens? If I take 3 and I square it, I get 9. So that means that 3 is the square root of 9. And what we write that as is square root of 9 equals 3. Okay. So it's kind of like we're defining it backwards. 3 is the square root of a, or of 9, because when I take 3 times 3, I get 9. So it's kind of this give and take sort of thing. But here's kind of an interesting thing. There's another number, b. So what if I took negative 3? What if I said b is negative 3? What if I said b was 27? I could say b is anything, but if I say b is negative 3, what happens? Well, I take negative 3 and I square it, and look, negative 3 times negative 3 is also 9. So when I take a square root of 9, there are actually two numbers that are its square root, both 3 and negative 3. So what I'm going to do is whenever we take the square root, the answer really is plus or minus. We're going to see we sort of favor the positive side, so we call that the principal square root, and if we haven't said anything else, we're going to say, well, that's the one we meant. But we want to, especially when we get to quadratics, we want to remember that taking a square root gives us a plus or minus. And it's right here, so it's because of the definition. If I square negative 3 times negative 3, I get 9. If I square 3 times 3, I also get 9. So there are two square roots of 9. Okay. And here we get into some more information. So every positive number has two square roots. That's what they're just saying. I just said that, right? I think I was more understandable, but we get a positive and a negative one. Okay. Just because like the 3 and the negative 3. So they call the positive one the principal square root, and usually they'll refer, when they want the square root, that's what they do it. That's what they're looking for. But sometimes they want that negative, so it's because it's there. Okay. Square root, we call this symbol itself a radical. We're going to see we use it in multiple ways, but I don't want to get ahead of myself. The stuff inside, I just call it the stuff inside. But if you want to get technical, you could also call it the radicand. Maybe I'll do that a little bit. Radicand, stuff inside, same stuff. And then whenever we have an expression, so it's not an equation yet, there's no equals, but we have an expression, something with a radical, we just call it a radical expression. So like here, 6 plus square root, radical x plus 2. It's got a radical part in it, so we call it radical expression. But it's also got a non-radical part, but that's okay. We still call the whole thing a radical expression. So just some examples there. It's more just so we understand each other when we talk. Okay, so evaluate each one. So 36, because 6 squared equals 36, right? Our answer here is going to be 6. And I guess actually it should be plus or minus 6, but we're just going to go for the principal square root. Okay, 0.64. Now you have to think a little bit. This is 0.8 because 8 squared, right? 8 times 8 gives us 64, and 0.8 times 0.8 gives us 0.64. So this is going to be 0.8. Okay. When we get to a fraction, 16 over 25, well, 16 is 4 squared, 25 is 5 squared, so this must be 4/5, and it is. Now, part of what we want to do is I came up with this little table. I just used it. So these are x values. Notice it just goes 1, 2, 3, 4, 5 all the way to 20. Then the next column, I use Microsoft Excel. It squares each of these numbers. So these are our perfect squares. And I'm a little bit ahead of myself because we're going to get cubes, fourth and fifth. But you'll see where these columns come in. So I could also look at this 36. I look at it over here. Oh, 36, that's going to be square root of 6 because it's 6 squared. 64, well, that's got to involve the 8. And then since it was 0.64, it must be 0.8. We play with that a little bit. Okay. And then we've got 25. So this helps you because some of us have not memorized all the squares. And certainly those who have memorized the squares may not have memorized the cubes. And if you memorize the cubes, which is amazing in itself, how many of you got to the fourth roots or the fifths? And we're going to see. Probably not. I'm not in that crowd. And then also I go all the way to 20 because some of these are going to give us problems. You know, I couldn't just pull off the top of my head that 256 is 16 squared. Give me a calculator, I could figure it out. But what I'm going to suggest you do with this, I'm going to post it in Canvas as well, is pull it off to the side as you do your homework, and it'll help you spot the patterns where these numbers are coming from. Okay, so we'll just tuck it down because we'll come back to it later. Approximate square root of 38. Now that's not on our list, right? We have square root of, we have 36. We've got 36, we've got 25, we've got 49, but we don't have 38. It's in between here. So what's going to happen is we're going to get some kind of decimal number, and really the only way we deal with these anymore, there is a method that was used to be taught, but now we got calculators. You just plug it in the calculator. It's 6.164. 6.164. Calculator method. So now we're going to jump to the next part of it. Is b is a cube root if b of a, if b cubed is a. So let's go ahead and stick with 3. If I cube 3, that's 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 more is going to be 27. Okay, so what we get is that the cube root, and when we use this radical, since the square root's already taken, we put something we call an index, and that's a 3. So on the square root, when we were doing square root of 9 equals plus or minus 3, we could have written this with a 2 up here. We could have put the index here, but remember when we do things like x to the first power, we just say, why do we, and then, you know, if x to the second power, we'll write it, but if x to the first power, we just don't write it. It's invisible. And when we do 1 times x, we don't write it, right? So with the square root, we sort of do the same thing. We just don't write it. So whenever you see this, we assume that that's going to be the square root. And you're going to see if you got a cube root, a fourth root, a fifth root, we're going to have an index here to tell us exactly what kind of root it is. Okay. But remember the square root, we got a plus or minus. What does that happen with a cube? And again, remember 3 is an odd power. So let's see, what if we would have put in -3? Do we get the same thing that 27 is also? I didn't finish this off, did I? Cube root of 27 equals 3. Is a cube root of 27 also equal to -3? Well, let's take a look. -3, cube it, what does that equal? -3 times -3, positive 9. Do down here. Oops. Get me back. There we go. So -3 times -3 is positive 9. But we got to multiply one more time. So 9 times -3, that's going to be -27. So it is not positive 27. The cube root of positive 27 is only 3. If we take the cube root of negative 27, we actually get, that's when we get negative 3. So when we have an odd power, an odd index, we're going to see these are also powers, but we'll get there. When we have an odd, we get separate. The positive is positive, the negative is negative. And we can actually do this. Remember, with the square root, we cannot take the square root of negative 9. Does not exist. Okay. But when we take the square root of a positive 9, we get a plus or minus 3. Okay. Again, we always favor the positive. So there's a page that's going to detail that out for us. So again, we look here. 64, and again we're looking for a cube root. So what cubed is 64? That's 4. So we're going to see the answer here will be 4. Negative 125. Well, what cubed value gives us 125? Well, that's 5. So negative 125 will give us negative 5, and then 1/8. What? Here's 8 is 2, so this is going to be 1/2. Okay, and again, it's looking at this chart here. So that's 4, just as we said. That's negative 5, just as we said. And that's 1/2, just as we said, because 2 times 2 times 2 is 8. Okay, so here's this definition of, it mentions this thing called an index. N is the index. So it's the number that's right here. It's also the exponent here. And there's kind of two different things that happen depending upon whether we're dealing with an odd or an even root. So first of all, if the thing inside the radical, the radicand, if it's positive, that's what this greater than 0 means. So if A is positive, then we say that this radical is going to yield us a positive number, whether it's odd or even. Okay, and we're going to say, yeah, that's what we're going to look for. Now, because that's the principal square root, remember we're just going to deal with that principal square root. If A is negative, so we got a negative in here. So there's two things that happen. If the index is odd, like to the cube root, then we see that we get a negative number. So we got like negative 27 cube root. So that's an example. There's an odd number. That is actually equal to negative 3. But if n is even, so I'll put the 2, it doesn't hurt. So 2 is even, and you try to take a even value of a negative number, you get does not exist. It's not a real number. Okay, that's what's going to happen. So if they're positive, we look for the principal square root, and with odd powers, it's also going to be positive. And so that's how it's going to work. So here's an example: 256 to the 4th power. That's even, so it has to be that way. Again, we pull this up. We look under 4th powers. We look at 256. 256 is 4 times 4 times 4 times 4. Okay, so our answer here is going to be 4. A 5th root of 243, so we look for the 5th power. Again, that's, it's 3, but who would know that? Not me. So that's why we have these little charts. 3 times to the 5th power is 243, so the 5th root of 243 is 3. And again, since it's negative, it's okay. This is going to be negative 3. But here's where we get that situation. The index is even, so there is no way to get to a negative number, because if you do something an even number of times, 4 times 4 times, multiply 4 times, the first two are positive, the second two are positive. Positive times positive has to be positive, okay? But so it's not going to be negative 6. It's not going to be positive 6. This one's just going to be no real answer. Okay, so there we get, because 4 times 4 times 4 is 256. This one, we looked that up. That's going to be negative 3, because negative 3 to the 5th is negative 243. And this last one, there's no answer. there's not a real number, so an even root of a negative number is not a real number. So watch for that. Don't spend too much time working through these, because since it's even, this is negative, we're done. We just walk away. The other thing that can happen, or not just can happen, does happen, is when you take the square root of a square, it's the same thing as taking the absolute value. And this is the reason why. So if you square a number, you'll always get a positive number. So if you take -3, square it, and then take its square root, remember these square roots sort of undo the square, because that gives us +9. Square root of +9 is 3. We do the same thing with +3. +3, 3 squared is 9. Square root of 9 is 3. And that's the same thing that happens with the absolute value. Absolute value of -3 is just defined to be +3. Absolute value of +3 is also defined to be +3. When we've used absolute value before, it almost seems like it's magic. It's just following a rule, but this gives us sort of a math way to look at it. Okay, so here we can say is before we do much, this is just going to be the absolute value of 5, which is 5, right? Square it. So you could go that this becomes +25. The square root of +25 is 5. That works. Or you could say, well, this is the same thing as absolute value of 5, so it's just going to be +5. Up here, the same thing's going to happen. We're squaring a square root, so these sort of just cancel out, and what's left is x plus 3 absolute value. Now we put these absolute values because x could be a number such that we would get a negative. But because we're going to square it and then take a square root, it's going to give us a positive value. This one we could work, but we got to get back to our factoring. So do you remember 9 times 9 is that? So that's got to be 3. So w, and we're going to add, but this tells us that they're negative. So w minus 3, which is the square root of w minus 3 squared, which again, the square root and the square sort of cancel out, leaving us with w minus 3, but the absolute value of w minus 3. Okay, that's all there is to it. This one, factor it first, do the canceling, and the answer is the absolute value of w minus 3. Okay. So evaluate these. So for this first one, we're going to plug in 1 for x. So you put in 1, that's 5. 5 plus 1 is 6. You'll see you'll get the absolute value, or square root of 6. And they're going to just leave it at that. Okay. If you plug in -2, -2 times 5 is -10 plus 1. You're going to get a negative value in here, -9, which is right. So plug it in, you get -9. So that's undefined. Yeah, I thought there was an E in there. I was having problems. Although I think that was the one. I did this first, I'm sorry, I'll tell you. And I forgot to click the record button. But that's just fine. I had a spelling error that I just now spotted. Okay. Over here, we put in 1. 1 squared is 1 plus 4 is 5. So that gives us a square root of 5. If we put in -2, now -2 is going to get squared, so that makes it positive. Positive 4. 4 plus 4 is 8, square root of 8. Okay. So we just go ahead and do that inside of square roots. We can also use square root functions. They are helpful in certain things, and it actually does give something called hang time when a ball is kicked. So it goes up 75 feet in the air, and the question, does the hang time double when the ball is kicked twice as high? So can you make a ball last longer? If you was a football player and you was a kicker, I did that for a little bit, but mostly because I didn't like getting hit. So the kicker usually could just kick the ball and run off the field. That was my side of the game. But let's see what happens. Hang time. We plug in 75 for x. We put it here. Using a calculator, they get square root of 75 times 1/2 is about 4.3 seconds. So to double it, if we go how far? So kick it twice as high. So that's 75 times 2. Kick it 150 feet in the air. Is it going to stick around for 8.6? So we double this, right? Times 2. That's the question. Well, let's see. We plug in the 150, do the math, and we come up with 6.1. No, it doesn't hang around for twice as long. It comes down, and that's because gravity works. It pulls it down faster somehow. So not quite, not twice as long. It's less than double. Okay. Now I think this is the last part we're going to look at, and that's finding the domain. And on the domain, what we're looking for is what would make this part produce an answer that is a real number. Well, think about what would produce a non-real number. The thing we can't have a negative inside an even square root, an even radical. Okay, so what we need is this inside part to be greater than or equal to 0. That means positive or 0. 0 is okay, just can't be negative. So, oops, here we go. So we're going to solve this. So you'll subtract 3 from both sides. They went pretty fast once we got subtract 3 from both sides. Then we divide both sides by -4. That's what they did down here. And when you divide by a negative, notice how the inequality symbol switched directions, flipped. Right? So x has to be greater than, or sorry, x has to be less than or equal to 3/4. If you do a number line, here's 3/4, here's negative infinity, here's positive infinity. It can be equal to, but it's got to be less than or equal to. So we're going to go from negative infinity all the way to 3/4 with a bracket on it for the domain. Over here, now notice whatever we put in for x, we're going to get squared, so it's going to turn positive. A positive plus 4 is always going to be positive. This one we don't really need to look at too much. We can put in any number and we will get a real value because the square root inside the square root will always be positive. So that's our domain questions, and that takes us to 7.2. I'm going to end this video here with just showing you what I want to show. Here we go. There's the Canvas. What you'll see is the videos will be in here by the time I get done with them. I'll post them. But I wanted you to see the homework. Let me come back here and just show you. I started putting in the homework. I've got 7.1 and 7.2. This is a Structure home. It's kind of slow. And I'll show you, I'm allowing you to kind of be flexible in your timing of when you want to do these things. I'll try to get a little bit ahead so that those who want to just kind of keep moving forward and get it done can do that. But here's a homework for 7.1, and then there's 7.2. So hit on it. They've each got about 10 questions. Go through, work through those, and you'll be fine and be ready for moving forward. Thanks.